Hello everyone. Today our main topic is about dimensions and calculations. This is a topic on basic mathematics, and in this topic first we will talk about area. So let's begin. What is area? So area is the measurement of enclosure. Like if someone give me a can of paint and ask to cover a particular floor or a wall, what would I need to know? So with the help of this can of paint, first I need to know the length and the width of that particular floor or of that particular wall, because I have to cover a surface to paint. So the amount of surface is called the area. So we can say that area is the measure of two-dimensional space inside a closed shape, and that closed shape may be a square, a rectangle, a circle, etc. It answers the question, how many unit squares does it take to cover this figure? So this unit square is actually the unit of measurement. What a dimension is basically, and what are one-dimensional, two-dimensional or three-dimensional. So first learn dimensions. In simple words, we can say that dimension is the direction, and that direction could be 0D, mean of zero dimension, 1D of one dimension, 2D of two dimension, or 3D of three dimension. Let's start with this 0 dimension. This is a point. This I put a point here. I mark a point here. We call this point a 0 dimension because everything is concentrated at a single place at this point. If something, so this point is in 0 dimension. If something is in 0 dimension, that it cannot move. It has no length, no width, no height or no depth. It is simply a point and mean nothing. Now if we connect 2 points, this point and we connect another point, so these point makes a line. Now this line is the combination of 2 points, and now this becomes one dimensional. This is a straight line now. I didn't draw a straight line, but consider it as a straight line. Now we get one dimension here. Now if an object is in one dimension, then it can move forward, or backward. So we can move this line forward or backward. Now if we join two lines, each of one dimension, like this is of one dimension line, and we connect another line with this point, so we get 2 points, two lines, one this vertical and the other horizontal. So this is called x-axis and this vertical line is called y-axis. Now this shape became two dimension. Two dimension have length and two width. Dimension can now move forward and backward, and left to right, left to right. Now we draw a third line like this, connecting these 2 points. Then this shape is a 3-dimension. We human are living in 3D world, so we can move up and down, left to right, and forward or backward, or objects in our life can move up, down, and left, right, and forward or backward. So this was all about dimensions. In dimensions, first we learn about area. For area, we use unit squares. If area is measured in square inches, then we say, or we write the result in square inches, like this, inch square. If we measure in centimeters, a particular area in centimeters, then we call it squared, or the area in squared centimeter. Similarly, in meter, then we can write the unit in squared meter. Now, how to calculate in area? Suppose, consider a grid overlay on a rectangle. Suppose a rectangle. A grid overlay means consider a that is called a grid overlay, which is made of small squares and big squares, and that is called graph paper. So the given rectangle, that is 5 centimeter long and 3 centimeter wide, this is 5 centimeter long and this is 3 centimeter wide. And let's suppose this 1 unit square is of 1 centimeter square. Then the whole area will be 5 times 3, that is 5 multiplied by 3 gives us 15 centimeter square. So this is how we can calculate area by using a grid overlay. So this is read as 15 square centimeter. Now this is the fundamental concept. Area is equal to number of rows and number of columns. Now deriving the formula. The first formula here we will derive is the rectangle. So I've already discussed this rectangular shape and you can derive this, like length into width, and you can get the formula. So area, where area is represented with A, and this A is length L times width W, where L is for length and W is for width. The second one comes the square. Now, a square is a special rectangle where all four sides are equal. That is, side, S for side, is equal to L for length and W for width. So if you want to derive it from that rectangle, then you just take side square. So side length, this S is for side length, and take square of it, S square. So this will give you the area of a square. Then is the parallelogram. The parallelogram is like a rectangular shape, but not exact rectangle, a slanted shape. So if we derive the formula of area for this parallelogram, and if we want to use this rectangle, then how we proceed? First, here I've made a shape for you. First, you extend this line of the parallelogram, then connect this with the bottom line with the base. So cut this rectangle from here and attached to the next side, to the next slanted side. So when you cut it from here and you connect it to this side, so this become again a rectangle. So again this will form the area of rectangle. So base into height, that was of length into height, and this is now, you need to be careful about base. So this base, there is a difference between base and length. So base into height, which gives you the same formula of the rectangle just after the rearrangement. The same thing is explained here. Here it is written. But if you don't want to do this, if you don't want to cut a triangle from one edge and connect to the another edge, just use this formula, where the formula is A is equal to base, B for base, and times height, multiply by height. So this formula, and it will give you the parallelogram, the area of the parallelogram. Next is the triangle. Now if you see, then the triangle is half of the parallelogram. When you half this parallelogram, you get two triangles. So if you want to derive the formula of the triangle from the rectangle, so what to do? You need to do the same. Like this is a rectangle, and you connect another rectangle, the same rectangle, to the other side. Like this is a rectangle. Now I'm connecting another rectangle to this. So this became parallelogram now. And now parallelogram is made of two rectangles. So for the area of this rectangle, the formula becomes half times base into times. So area will be, means a rectangle is half of the parallelogram. 1 by 2 multiply by base into height, like this. This is the formula. Next, the circle. Now the circle don't have straight lines, but if you want to derive it from the rectangle, then what you need to do? Remember, the center point is this, half of the circle is radius. Want to derive the area of a circle from a rectangle, so we made this circle, or we cut this circle into small slices, like if you cut pizza in a small sizes like this, and then rearrange like this to form a rectangle. So this way it becomes a rectangle. So this is the radius, like this, the same radius, and this is the shape near to the rectangle, but this portion is pi r, and this pi r with this r, again using the formula of the rectangle, pi r into r, meaning length into width, so pi into r, so area becomes pi r square. So if you don't want to do this, or you don't want to derive it from the rectangle, just use the formula, direct formula, and that is pi r square. This area of the circle is equal to, area of the circle is equal to pi phi, this pi into r square, where r is the radius, pi is given, its value is already approximated, and it is like this. This is phi, I think so, or this, where r is for radius. Okay, radius will be given, and or you can calculate it, and then you use this approximated value to find the area of a circle. Okay, why dimensions matters? Why we need dimensions? Why unit measures? So it matters because in geometry, dimension tells us what kind of measurement we are performing. That is one dimension, length, or width or height, parameter. These are linear measures. Its unit may be centimeter, meter, inches, and in feet. But when you do two dimensions calculation, then it becomes squared. So square centimeter, squared meter, square inches, squared feet. This matters because if you accidentally multiply a length by a square centimeter, you get this centimeter cube, and the answer will be wrong. Lecture, we calculate area for two-dimension shape. Thank you.